Okay, so we've seen the problem with the schema drift, but before fixing this problem, let's talk a little bit more about serialization. You probably see we implemented this in code. Let's see what it's all about. So serialization is nothing more than the process of turning data structures into bytes so they can be stored or sent through the network. So I've been telling you guys repeatedly that Kafka stores only bytes. It does not understand Python objects, okay? So why does this matter? Because serialization is the language that both sides will agree on, or the contract of how bytes map to fields. So we really need the producer and the consumer to be speaking the same language in terms of how the bytes are going to be mapped into the fields. So that's why we need to be able for them to use the same serialization process. Because without this consistent rule, the producer and the consumer might interpret the same bytes differently. So let's look here into our diagram first. We have a Python dictionary, so it's a Python object that the producer is producing and sending to the topic. So it first sends the message, it goes through the serializer, and it is modifying the message just like this, turning this into bytes. Then it sends the message to the topic. The topic has it stored as bytes. Then the consumer needs to deserialize it to get back to the original format, and then the consumer is able to deal with that information. So in this scenario one, both the producer and consumer, they're using the same serialization format. So you can see it turns on the same message. But now let's say that the producer, we have a Python dictionary. It is serializing using a JSON serializer. So here we have a bytes, like converting this, sending this to the topic, but then the consumer is using an Avro deserializer. So it's fetching this message, trying to put this into the Avro deserialize it, but it's going to fail because it has an incompatible format. So then the consumer is not able to receive that message. In this case, the producer and consumer are using different serialization formats. So speaking of those, here are some common serialization formats that we use. JSON, which is text-based, very human-readable, slow and verbose, and you can see that it has some characteristics like it's very difficult to do schema evolution. We're going to take a look at this later. That's just best for simple debugging and APIs. It has a poor compressor and things like this. We also have Avro. So Avro, it's not text-based, it's binary, so it's not human readable, but it's very fast and compact. Okay, this is excellent for evolving schemas. We're gonna take a look at this. It's very used into streaming and data pipelines. So our project, we're gonna use Avro serialization. It has a very good compression, and it's typically used in Kafka, data lakes, schema registry. You're going to look in this and things like this. We also have Protobuf, which is also binary, still not human readable, also fast and compact, but it do have a limited functionality in terms of evolving schemas. It requires that the field numbers must remain fixed, and it's mostly used in gRPC, and internal APIs. Okay, so these are the most common formats for serialization, and what we want to do before fixing the schema drift is make sure that both the producer and the consumers are speaking the same language when they are transmitting that message to the broker and the topic. So when the producer is sending and the producer is receiving, they are like correctly matching the serialization format that has been agreed.